So far, it's demonstrated that they're using the same structures in their brain to recognize threats and rewards as we would.
You've probably shooed a crow off your trash cans at some point and never thought about it again. However, that crow most likely remembered your face for years afterward and told other crows exactly what you look like. It even passed that warning down to chicks that hadn't even hatched yet when it happened. Scientists have long suspected that crows were far smarter than we gave them credit for. Now, researchers have started feeding thousands of hours of real crow recordings into AI built to find patterns humans can't hear. And what's coming back is forcing scientists to rethink what these birds actually understand about us. The question isn't just whether crows are smart, it's what they've been saying about you this whole time. Let's get into it. The feathered apes. Crows belong to a family of birds called corvids, which also includes ravens, magpies, and jays. Scientists have taken to calling this group the feathered apes, and it's not just a catchy nickname. It is a direct comparison to mammals, because these birds are capable of the kinds of intelligence that were thought to be limited to mammals. Intelligence such as problem-solving, tool use, memory, and the ability to learn from one another. That comparison would have sounded ridiculous to scientists just a few decades ago. You see, for a long time, biologists assumed only mammals were capable of real problem-solving. This was further emphasized after Jane Goodall's famous 1960 discovery that only chimpanzees make and use tools. Birds, by comparison, got written off almost completely. Partly because they lack a cerebral cortex, the brain structure mammals use for complex thought. What researchers eventually figured out is that birds evolved a completely different structure to do the same jobs as a cerebral cortex. That is, the pallium. This is often confused as the bird version of a cerebral cortex, but it's a completely different structure doing similar work. And relative to body size, a crow's brain is remarkably close to a chimpanzee's. They even recognize individual faces and pass that knowledge down to their young. The most famous demonstration of this came from a 2006 study at the University of Washington, led by wildlife biologist John Marsluff. Marsluff's team trapped a small number of wild crows on their university campus while wearing a rubber caveman mask. Then, they released the crows. From that point on, researchers referred to those masks as dangerous masks. They wore the same dangerous mask only when doing something threatening near crows. A separate team wore another set of masks when doing anything harmless. They called these the neutral masks. Years later, when Marsluff and his team walked back onto the same campus wearing the dangerous mask, the crows had not forgotten. They encountered a total of 53 crows. 47 of them attacked the people wearing the dangerous masks on sight. The neutral mask drew no reaction from the crows at all. What made this genuinely remarkable is that only a handful of crows had ever actually been trapped in the initial experiment. But the recognition and the hostile behavior had clearly spread to far more crows than had ever encountered the mask. The same research group used PET-style brain imaging on captured crows to see their brain activity. They compared their neural activity after seeing a threatening face versus a neutral one. The results were groundbreaking. The crows showed distinct activation in brain regions associated with fear and memory formation when they saw the dangerous masks. Exactly like the patterns seen in mammals processing a genuine threat. Something in the crow's brain was treating the specific masks as a stored, emotionally tagged memory. That study proved two things at once. Crows remember individual faces and behaviors of humans, and they actively communicate that information to other crows, including offspring. The experiment showed that information about humans could spread through a crow society, and that raised a much bigger question. If crows could learn, remember, and socially transmit information this complex, what else were their minds capable of, more than instinct? Remembering a face proves crows have memory. But memory alone isn't the same as reasoning. To understand how sophisticated a crow's mind really is, researchers needed to test whether these birds could understand cause and effect. Before chasing their language itself, researchers first had to prove the mind behind it could handle that kind of complexity at all. In 2014, researcher Sarah Gelbert at the University of Auckland ran an experiment on New Caledonian crows. She was inspired by the famous tale from Aesop's fable about a thirsty crow dropping stones into a pitcher to raise the water level. Gelbert used clear plastic tubes with a piece of floating food inside them. Some tubes were designed so that dropping stones in would actually raise the water high enough to reach the food. Others were rigged so it wouldn't work no matter how many stones went in. The crows were tested repeatedly, and they consistently chose the tubes that would actually work, and largely ignored the ones that wouldn't. They weren't just repeating a trick. They understood why it worked. And the laboratory wasn't showing researchers something completely foreign to these birds. In the wild, crows were already solving problems that demanded the same kind of reasoning. New Caledonian crows are famous for manufacturing their own tools. They'll snap a straight twig and carve a small hook into one end using their beak, making a tool precise enough to pull a worm cleanly out of a hole in rotting wood without crushing it. They also cut and tear strips from pandanus leaves, which have naturally barbed edges, turning the leaf itself into a makeshift rake for dragging insects out of leaf litter. Carrion crows in Japan place walnuts on roads for passing cars to crack open. Then they swoop down to collect the pieces. Taken together, these behaviors point to something scientists call causal reasoning, which is understanding not just that an action works, but why it works. By this point, researchers had established that crows could remember individuals, learn socially, and solve physical problems through cause and effect. But one mystery remained. What were they actually communicating to each other? Building an AI that listens. The problem scientists were faced with was that intelligence is easy to observe, but decoding communication is much harder. A crow could solve a puzzle right in front of a scientist. That would prove it has intelligence. But how do you decode what it's saying? For most of scientific history, there was simply no way to tackle that issue. That's exactly the problem a real, ongoing research collaboration has been trying to solve since 2024. Researchers Dr. Vittorio Baglione and Dr. Daniela Canestrari at the University of León in Spain have been working with a nonprofit organization called the Earth Species Project. They are currently using AI to study an unusual population of carrion crows in northern Spain. The researchers chose this specific population of crows for two reasons. The first one is that carrion crows in northern Spain have an unusually cooperative family structure. Adult offspring often stay with their parents for years to help raise younger chicks. Coordinating that much shared parenting requires a lot of communication. That is why researchers suspect their vocal communication might be holding more secrets than anyone previously thought. The second reason for choosing this specific population was that the researchers had already spent decades studying this specific population, which means the project isn't starting from zero. They are combining decades of fieldwork with an AI model built to process what no human ear could ever sort through. The first and biggest problem was gathering enough authentic crow recordings to actually train an AI system. For this purpose, the team deployed tiny biologging tags. These tags were fitted with microphones and motion sensors and put directly onto wild crows. Over multiple breeding seasons, these tags picked up more than 127,000 individual vocalizations. The problem was no longer collecting the sounds. It was making sense of them. And the volume of data was far more than any human team could sort through. That is where the artificial intelligence entered the picture in the form of a language learning model called Voxaboxen. The researchers used the 127,000 captured recordings to train it to detect and categorize crow vocalizations. The recordings immediately revealed something researchers had been missing. Much of the communication wasn't loud at all. A huge amount of soft, low-volume murmuring that standard microphones from a distance would never have picked up at all. It turns out, a large share of crow communication may be happening at close range. Quiet exchanges between birds sitting right next to each other. Researchers described these early results from the AI as something like assembling the first pieces of a Rosetta Stone. Not a finished translation, but a structured map that separates calls from tagged adults, other adult relatives, and chicks. And once the AI started separating those sounds, the oldest assumption about crow communication began to fall apart. This was the idea that all crow calls break down into a short, fixed list of signals, similar to a traffic light switching between red, yellow, and green. That assumption broke down completely. The AI analysis showed that beyond the loud, familiar caw everyone recognizes, there is an entire layer of quieter, more nuanced vocalizations. These are impossible to hear for human ears, because they simply aren't loud enough to register at any real distance. The AI model also gave researchers an entire data structure from the captured audio. Distinct clusters of sound, tied to who was calling, who was nearby, and what was happening in that moment. The AI showed that crows aren't just reacting to the world around them. They may be actively describing it to each other. But finding more patterns wasn't the same as knowing what those patterns meant. The AI had given researchers a map of the crow's vocal world. The next question was whether anyone could actually read that map. What the data actually shows. The AI has shown that crow communication contains enough variation and structure to be studied as a system rather than just a collection of random calls. Researchers can now begin asking whether particular sounds consistently appear with particular individuals, situations, social interactions, or behaviors. And that's where the discoveries we've already discussed suddenly become more important. Crows can remember individual humans. They can learn from other crows. They can pass information through their social groups. The important point isn't any one of these discoveries on its own. It's what happens when you put them together. Crows aren't simply producing random sounds. They're using a vocal system that tracks individuals, social relationships, and what is happening around them. And researchers are only now beginning to map that system. But mapping a communication system is one thing. Identifying what individual signals actually mean is another. And that's where some of the behavioral evidence becomes especially interesting. Crows have been observed leaving small objects near people who consistently feed or protect them. This was most famously popularized by a young girl in Seattle who built an informal gift exchange with her neighborhood crows over several years. It's a real, charming, well-photographed phenomenon. And the most amazing part of the story? The AI was able to decode a specific call that the crows kept making when they came to visit the girl. The crows made the same sound every time, and researchers have termed that the crow's gratitude call. If that interpretation holds up, it would suggest that researchers aren't simply finding patterns in crow communication. They're beginning to attach meanings to particular sounds. But that still falls far short of a complete dictionary. We don't have a Crow-to-English translation system. What we have is the first evidence that patterns in these sounds may correspond to specific behaviors and relationships. But recognizing faces and coordinating warnings is one kind of intelligence. What researchers have documented around death and social learning in crows points towards something impossible to write off as instinct. Grief, culture, and learning from neighbors, vocal complexity is only half the story. The more researchers watched crows in the wild, the more another pattern became impossible to ignore. These birds weren't simply communicating information. They were learning from one another. When a crow dies, nearby crows will often gather around the body in a behavior researchers have taken to calling a crow funeral. It has been studied in detail by researcher Kaylee Swift from the University of Washington. Unlike many birds, which simply move on, crows in these gatherings tend to go quiet. They circle the area and sometimes even approach and examine the body directly. The leading interpretation of a crow funeral, according to Swift, is that these gatherings are primarily about information gathering, learning what killed a member of their group and whether the same danger is still nearby. But the stillness and unusual quiet during these gatherings is exactly what makes the behavior read as something closer to mourning. Whether or not we call it grief, the important discovery is that these gatherings involve learning. And learning from other individuals is something that appears throughout crow society. Researchers have also documented real regional variation in crow calls. Different populations develop distinguishable local patterns. It is similar in concept to a regional accent. That kind of regional variation is evidence that at least some aspects of crow vocal behavior are socially learned rather than completely hardwired. It is a real form of cultural transmission and not something hardwired from birth. And the ability to learn patterns doesn't stop with other crows or human faces. Some populations have learned to anticipate human routines as well. A 2019 study in Austria's Rhine Valley and a study in Kochi, Japan in 2024 both pointed towards the same thing. Crow populations adjust their foraging habits around specific human schedules. They show up near known feeding spots or garbage collection routes at roughly the times they've learned food tends to appear. These studies are even more evidence that these birds are actively tracking human routines and adapting their own behavior around them, not just reacting moment to moment. Which brings us to an interesting part of the story. Crows aren't simply responding to humans. They're learning our patterns and adjusting their own behavior around them. A two-way street. It's tempting to frame all of this as a one-directional story in which humans are slowly gaining the ability to eavesdrop on a secretive animal society. One that's been operating right above our heads the whole time. But the real and accurate picture is messier and more interesting than that. Crows have spent an extraordinarily long time adapting specifically to human environments and human behavior. Far longer than humans have spent seriously studying them back. The mask experiment showed us something uncomfortable. While scientists were studying crows, the crows were studying the scientists right back. In a very real sense, humans have had a crow reputation long before any AI model existed to analyze it. The recent AI work doesn't represent a sudden change in crow intelligence. It represents a change in our ability to detect it. The crows didn't suddenly become more complex. Our microphones and algorithms simply became good enough to notice complexity that was already there. Researchers involved in the Earth Species Project's work have made a similar point about their parallel research into other species, including orcas. They said that the goal isn't to prove animals are secretly plotting something. It's to finally have the tools to properly listen to communication systems that were always more complex than we assumed. That reframes the whole story. This isn't really about catching crows in the act of talking about us behind our backs, dramatic as that framing is. It's about scientists finally catching up to a level of social complexity these birds have quietly been operating at for a very long time. Why this actually matters. And that isn't just a fascinating scientific discovery. Understanding how animals communicate can have consequences far beyond satisfying our curiosity. The same tools being developed to understand healthy crow populations could become especially valuable when researchers study species that are already disappearing. The stakes become very real when you look at a close relative of the carrion crow being studied in Spain, the Hawaiian crow. It is a species intelligent enough to be capable of using tools, and it went extinct in the wild back in 2002. Now, the only survivors of the Hawaiian crow exist in captive breeding programs. Researchers are applying the same AI-driven approach to map how that species' vocal repertoire has shifted across generations in captivity. This is information that could directly shape how future reintroduction efforts into the wild actually succeed. In other words, understanding what a species needs to communicate among themselves might end up being a part of what saves it. We thought crows were reacting to us. We now know they're remembering us, learning from each other about us, and adapting to us. AI isn't creating that intelligence. It's finally revealing it. For a very long time, we assumed we were the only ones paying close attention to other living beings on the planet. It's becoming increasingly clear we've had company the entire time, watching from the power lines, quietly keeping score. Crows are watching, remembering, and talking about us in ways scientists are only now starting to properly measure. That's not science fiction. That's published, ongoing research, finally catching up to what these birds have been doing all along. So, what do you think crows would say about you if they could tell you directly? Let me know your thoughts about this in the comments below. And if you enjoyed this video, make sure to like, subscribe, and turn on notifications so you never miss the next mystery we dig into. Thanks for watching, and we'll see you in the next video.